In this video, we will be talking about some of the more advanced concepts that is present in the SQL language. Now, we know SQL to be a complete database language. That means that it has two components. It has a data definition component and it has a data manipulation component. As a data definition language, it allows us to create and define the structure of tables and views. We can define constraints on the table, we can establish relationships between tables, we can specify the data types of attributes in the tables, and subsequently it is a very comprehensive data definition language. In addition to being a data definition language, it is also a data manipulation language. It allows us to specify queries and also allows us to write statements that allow us to maintain a database through the use of insert, update, and delete statements. However, SQL is not a complete programming language. To get the full use of SQL, it needs to be used in conjunction with a complete programming language such as Java, C#, Swift, PHP, and we see COBOL over there. Not that much COBOL going around nowadays, but you could use it with COBOL if you had to. Fun fact, COBOL was one of the first programming languages I learned. SQL has many different versions, and one of which is embedded SQL, and we'll talk a little bit about this later on. As I mentioned, it is a data definition language, and so tables, views, indexes, so on and so forth can be defined while the system is operational. These tables are created using the create table statement, and each table has a name, and this name is preferred not to be a keyword or a reserved word in the SQL language. As a data definition language, SQL also allows us to establish constraints. We're all familiar with the primary key constraint, where it basically does not allow us to have duplicate values of the primary key. We also have the foreign key constraint, and the foreign key constraint is basically relating two tables that have a primary key foreign key relationship. And SQL also allows us to have a unique constraint that makes sure that values in a column are unique. We can also develop additional types of constraints. We can have constraints on tables, and we can also have constraints on columns in a table. And so SQL is a very flexible language that allows us to do a variety of different data definition type things through the use of these kinds of constraints. SQL also supports a variety of different data types. We have the Boolean, numeric, a variety of string data types, a variety of numeric data types, datetime data types, object data types. SQL is always being extended such that it can support newer and newer types of data. There are spatial data types as well that can be supported. There are XML and JSON data types that are also supported based on the database server. And so supporting multiple types of data is one of the goals of the SQL language. Now, one can always get a list of the supported data types for the database server based on the manual for that database server. We can also format the structure of the data using the format function. We can format date time data, and we can format numeric data. Now, one of the important aspects of every database is that it supports a variety of different languages. Databases are used all over the world, and different languages have different characters in their particular script. Databases support different languages. The characters of a language or a script are defined as part of the collation sequence. A variety of different types of correlation sequences can be specified, and they can be specified at different levels. They can be specified at the level of the database server, the level of the database within the database server, the level of the table, and the level of the column. A good practice is to specify the correlation at the database level, and if you want a specific correlation for a table or a column, you can modify it. In addition, correlation allows us to also specify whether the database table or column is case sensitive or case insensitive as it relates to the data within the database table or column. Now, SQL as a data definition language also allows us to alter the structure of a table, and we can add columns to the table, but we cannot change the storage format of a table or a column. And one of the reasons we can't do that is because if we change a column storage format, we might actually lose data. And we cannot also delete unwanted columns using the alter table. So we can primarily add one column at a time using the alter table statement. We can drop tables, and drop tables allow us to delete tables from a database. We can also create views in SQL, and as we know, the views are definitions of a table and not the table themselves. And we can create multiple views. And to drop views, or to delete views, we can use the drop view statement. We can also create indexes. Think of indexes as a fast way for a database to look up data. The purpose of an index is so that the data in a column can be quickly looked up and referenced based on query needs of data analysts. Multiple indexes can be created on a table or on a database, and these indexes can be dropped using the drop index statement. Now, there are a variety of data manipulation statements. Insert, update, delete, and select statements are all considered data manipulation statements. The insert statement allows us to insert one row or multiple rows based on queries. Update allows us to update one row or multiple rows, or update all rows. Now, sometimes one might come across a situation where a database server does not allow us to update multiple rows at one time. Sometimes that could be a security feature that's built in that requires us to update one row at a time only. Similarly, we can delete one row, multiple row, or all rows. Again, some database servers might not allow us to delete multiple rows or all rows and require us to delete one row at a time. And again, this is based on the configuration of the database server. Now, when one has multiple tables, we are familiar with the idea of joining the two tables based on the primary key foreign key relationship. But one can also have the product of two tables, where the first table is concatenated with all possible rows of the second table. And that is the statement to accomplish that, based on the stock and nation tables. A join is a way to create a new table from two existing tables by matching on columns common to both tables. The typical type of join that we've looked at is the equi-join or the inner join or the regular join. There are other types of joins possible, such as left join, left outer join, right join, right outer join, and full outer joins. Here is what an inner join would look like, or a regular join. This is a left join, a right join, and a full join. MySQL does not support a full join. Now, one of the more complex queries that one can write in MySQL is the correlated subquery. A correlated subquery is where the inner query is evaluated many times rather than just once. The inner query is executed for every row that is evaluated as part of the outer query. We have seen examples of correlated subqueries previously. A correlated subquery is the norm when one is using an exists or not exists clause. There are a variety of functions that are available within SQL. These are the basic aggregation functions that one can run in SQL: count, sum, average, min, and max. These are not the only aggregate functions that can be run, but are the most common ones. SQL routines are operations that can be either manually triggered or automatically executed by the database. There are three different types of SQL routines. The first one is a function, the second one is a procedure, and the third one is a trigger. The purpose of an SQL routine is to increase the flexibility of a user's interaction with the database. It improves productivity and allows us to enforce business rules. While we have used SQL functions that are built into the database server, one can also write their own SQL functions and store them on the database server. One does that through the use of the create function statement. The create function statement requires that the function return a value, and that value, when returned, can be used as part of a select statement, for instance. Sometimes functions may take inputs, and sometimes they may not. An SQL procedure is SQL code that is loaded and executed based on a call statement. An SQL procedure has to be invoked by the user. An SQL procedure is created using the create procedure statement. SQL procedures can be pretty complex. Procedures are defined and involve the execution of simple or complex SQL statements. SQL procedures may take inputs and multiple inputs, and sometimes return outputs or multiple outputs. Once a procedure is created and stored, it can be invoked using the call statement. If the procedure takes inputs, as part of your call statement, you are going to have to specify the parameters or inputs that the procedure is expecting. A trigger, on the other hand, compared to a function or a procedure, is a set of statements that is automatically executed by a database server. A trigger is automatically executed when there is a change in the state of the database. Something that changes the state of the database are update statements, insert statements, or delete statements. These statements involve something actively changing in the database. And so, these statements can actually set off a trigger. Again, a trigger is created using the create trigger statement, and after the create trigger statement, a set of statements describes what the trigger is supposed to do. Now, most tables do have null values. Null values should not be confused with blank or zero values. Sometimes one might have columns that have no data, or one might have rows that have no data. And so one shouldn't ever think of a null value as a zero or blank value. We can have a variety of reasons to have null values, and sometimes null values create confusion because the user must make an inference about what the null value means. Now, one of the important features of a database is data security. We all realize that data is a valuable resource, and so access to the data should be controlled. There are very different ways that security can be provided to data, and one is through the use of views. Views, as we know, are temporary tables or definitions of tables, and one can create views to only allow users to see what one wants them to see. Another type of security procedure is through the use of authorization statements, authorization commands. Authorization is based on the concept of privilege. Without the appropriate privilege, you cannot execute an operation. And the database administrator has all the privileges and decides who gets what sort of privilege on a database, a table, a column. Privileges are assigned using the grant statement. The structure for grant statement is as follows: grant a privilege on an object in the database to users. Privileges are what are the kinds of operations a person can run. Privileges can be either all privileges, giving them any and every type of privilege that is possible in the context of the database, such as select, update, delete, and insert, or specific privileges. So one can grant select privileges, or update, or delete, or insert privileges. The on clause of the grant statement allows us, if you want to grant a set of privileges on a complete database, on a table within the database, or on a column within a table in a database, to the users we want to grant them to. Sometimes there are ways the grant statement can be extended, and so we can also provide alter and index privileges, but that is only typically to the base tables, and with grant option allows a user to pass the privileges that they have to other users. Here are some examples of grant statements. While one can grant privileges, one can revoke privileges as well, using the revoke statement. Again, the format of the revoke statement is revoke a privilege on an object in the database from a user. Now, one of the most common types of attacks on database servers are injection attacks, or SQL injection attacks. The idea behind SQL injection attacks is when one has a web form, one can, instead of providing information that the web form is requesting, one can actually write SQL code as input to the web form. That SQL code, when passed to the database server, can execute database-related statements. And consequently, we have an injection or an SQL injection attack. One can prevent the SQL injection attack using parameterized queries. Ways to avoid SQL injection attacks is to limit the authorization of the connection, the database connection from the web form, to be only select, only statements, and to make sure that the data that is coming in is validated. Lastly, we can also use parameterized queries as part of the web form. One important aspect of a database is the database catalog. A database catalog contains definitions, or a database catalog is the metadata about the database. It contains information about the base tables, views, and other aspects of the database. And the catalog can be queried using SQL. In MySQL, that catalog goes by the name of information schema. Here are some different queries that one can actually write on the catalog. Now, SQL is a full-featured database language. But we know that SQL is not a standalone programming language. SQL statements can be embedded in other application programs, and that is where we have embedded SQL. SQL is a success story of standardization. Uh, SQL is a very portable uh, database language. It can be used across a variety of operating systems, across applications and organizations. SQL is a constantly evolving language, and it has been evolving to meet contemporary organizational challenges. One can expect SQL to stick around for a long, long time, being the database technology of choice for most organizations well into the future.